Can you hear me, Molly? Okay.
Yeah, I can hear you now a little bit.
Can you hear me now?
Yeah.
Okay, is it clear now?
Yeah, it's a little low. I'll just turn my volume up.
Okay, I'm just gonna untangle my earphones here. I can try it without, but I think it's clear with, so I'm just gonna untangle them. That might be the issue.
I think it's some weird, I'm just gonna check if I have two open or something because it's making a weird sound. Yeah, I don't have my headphones on. I'm getting a lot of feedback. So like when you speak and when I speak, maybe I need to get out and come back in again, or is it just because it's loading? Do you think? Yeah, I'm just not. I don't have my. Please start recording.
Okay. So I'd like to welcome you to our session tonight, Make Patterning Come to Life with Coding with Lisa Floyd. It's always great to see people from all over Ontario joining us for the OTF Connect sessions. And I know that you're in for a really exciting night learning about another one of Lisa's sessions, learning about coding in the classroom and applications. So I'm just going to turn it over to Lisa. Thank you very much. Okay, thanks very much, Molly. How's the sound? Am I loud enough? Hopefully. Yeah, I think so, yep. Okay, great, thank you. So I'm excited to share with you some ideas for integrating coding into your patterning lessons in mathematics. And we're going to be using a couple different platforms this evening. And I know you might have received an email, and Molly mentioned as well, that it might be good to have that second device with you, preferably a computer, or laptop, or a Chromebook. And that way you could be watching the webinar and then be on the other computer typing, trying to follow along. You can also split your screen, or you can just watch, and I will be doing it on the screen. And you can even, because this is being recorded, you can watch it later and try it again as well. So many of the ideas that I'll be sharing with you are research and ideas from professors whose work I find fascinating, and I'll mention their names as I go along here. So I've been working with Fair Chance Learning, and so we go around Canada, different school boards, supplying them with professional learning related to coding and computational thinking. I'm also an instructor at Western University for a course called Computational Thinking and Mathematics for all primary junior teacher candidates. So they do take a 9-week coding course with me. And I also teach the IS Computational Thinking course for mathematics and science. I'm also doing my master's in math education right now. So I have the privilege to work with professors whose focus is on computational thinking. And as a research assistant, I get to go into classrooms and try different things out. And I'll share with you one of the articles that we published, or a bit about one of the articles we published tonight, just to show you what we've been reading or researching on computational thinking. If you are on Twitter, I'd love to connect. It's Lisa Ann Floyd, and you can see my handle there, and with an E. I've also been teaching, by the way, in Thames Valley District School Board in London, Ontario for 14 years, and I've been teaching computer science, math, science, and some cooperative education. So as I mentioned, we are going to be using a couple different platforms today, including Scratch. And Scratch is an online platform that will not work on an iPad, but it will work on a laptop, PC, Mac, Chromebook. And then Python will work on any device. It's an online console that we're using. You don't have to download it. You'll just be trying some text-based coding online this evening. That may be a first for many of you, so I'm excited to share that with you. I'm going to stretch some of your minds tonight, but you can always watch this again if you like to come back. I'd like to do a little poll here. I just want you to rate your current coding experience. I have an idea who I'm working with this evening. If you can let me know either in the chat window, or there is Molly's got the pull down menu there for the letters on the just below your name. You should see that. And you can see some people are filling that out now. So if you could rate your coding experience based on limited, some, considerable, and thorough, that would be great. And I can also see the chat window, so that's helpful. Like, either one is fine. Okay, so it looks like most people are limited or some, and a couple considerable in there. And feel free to ask questions as you go along in the chat window. I will respond to those, and if I miss it, I'm sure Molly will let me know. And also, if you have any suggestions, if someone is asking a question, you can also help them out if I miss it. So feel free to add in your own tips. You're welcome to. So it's typical that most people don't have a lot of coding experience, and so don't worry, we'll help you all along, and I'll also try and challenge those of you who have a bit more coding experience. So as you know, patterning is across the grades, and even if you teach grades 4, 5, 6, you should know that it does start in grades 1, 2, and 3. It's important that students see the connections across the grades from year to year. The research shows that they're, when they see the connections to previous and future learning, they just do better in math because connections are important in mathematics. So I just have all of the grades listed here. And then you can see the grades 7, 8. So we're going to be focusing on mostly grades 7, 8, but certainly you can try out some of these ideas. And at the beginning, I'll share with you some junior ideas. So we're going to look at some growing patterns with numbers tonight, as well as some basic stuff with images. So we're going to start off with a little exercise that I did do really quickly on another webinar, the most recent one that I did on patterning for the primary junior grades. But the point of this is to show you the capabilities of Scratch. I know some of you have used it, but we're going to be using this a little later to do some more advanced number patterns. So I thought it would be neat if we try this out. So if we can watch this video together now. I'll let, I think Molly's going to bring that up for us. Can you hear us, Molly?
Yeah, I have to go get that link. Just I'm doing the attendance too, so just hold on a second.
Oh, sure. And those of you on a iPad, you can actually type this in and watch it yourself right now. It's just a very quick 30-second video to show you what we're about to make. So that's it. Now you've seen what we're going to be making together. Once it gets back to the screen, I'll walk you through this quick program. Okay, so we're going to go to Scratch right now, and I have the website listed for you here, so scratch.mit.edu. And yeah, I was hoping it would become a clickable, but what you can do is when you're in Scratch, so I'm going to share my screen, so you can go to scratch.mit.edu and you can go to Create. So I'll try sharing my screen now and walk you through this little program, and then we'll get into some more advanced number programs together. Okay, so this is the screen that you should come to. What you're going to do is click on Create on the top left. And we're going to make a really simple program. All it's going to do is do like an A, B, C pattern, and it's going to repeat. So the first thing you're going to do is click on Events and grab the when the green flag is clicked. You will notice on the bottom right that you should be able to make your code a little bit bigger. So if you're sharing this in front of the class, you can click on this plus sign on the bottom right. Now we're going to go to Look, okay, and we're going to switch the costume. But before we do that, we're going to take a selfie or an image of yourself. So you're going to click on the costume. You can see the Costumes tab. So I'll just do that again. I was under Script at the top. You can see Script. That's where all the block coding is. And if you haven't used Scratch before, don't worry. You just have to get playing with it, and then you'll feel that you get more and more comfortable with it. So just ask questions if you have any for me. And I can actually see what you ask right now because I have a second device. So if you have any questions, you can just feel free to type them in the chat window. So what you're going to do is go to Costumes at the top middle. And you can see that the two sprites, the sprites are little characters, come up. And we're going to create a new sprite, but rather than take one from the library, you're going to click on the camera and take an image of yourself. So click on the camera. And you will have to click on Allow, so make sure you do click on Allow so that it allows access to your camera. And so you can see me in a second. Okay, so there I am. And I'm going to take a picture of myself with my thumb up, so that'll be my first picture. So you click on Save. And now I have a picture of myself. I'm going to take two more pictures now by clicking on the camera, so just let me know if you have any questions. So my second one, I'm going to do a different picture. Okay. And one more. So we have 3 different images for our ABC pattern. So there's my last one. So now you'll see your 3 images once you take the pictures of yourself under Costumes. And you can get rid of the 2 tabs. To get rid of them, you just click once on them and then hit the X to delete them. And I'm going to click on the other cat to delete that one as well. And then I'm going to return to my script. Now what you can do with your students, and it depends on the age of course, you can actually rename these. So you can see right now they're called Photo 1, Photo 2, and Photo 3. But what you might want to do is have them rename them. It just depends on the grade level you're working with. If it's a really young grade, you probably just want to leave them. So we're going to go back to script. So now you can see I'm back to my code, and I'm under the Looks tab. So the Looks tab is the purple one. I'm going to start off by going to Switch Costume. So Switch Costume 2. Right now it says Photo 3 in my pull-down menu. I'm going to change that to Photo 1. I'm then going to add a sound. So under Sound, you click on the Sound tab, and I'm going to play a note. So if you click on the note, Play Note, and so you'll notice that if you click on the little 60 there, so 60 is middle C in all programming languages, you can choose which note you'd like to play, and it's neat that the keyboard comes up. So I'm going to start with middle C, and notice I picked a block that has something that says for half beat. So do make sure that your students are picking one that has a beat or some sort of weight in there, because otherwise it'll just skip to the next photo and it will confuse everyone. So that's the best one to use right now. I'm going to go back to Looks, and I'm going to add my second and third photo in. So Switch Costume 2, Photo 2. And while I'm in here, I'm just going to drag out the other block since I'm already there. So now I've got Switch Costume to Photo 1. I've got the Play Note, Photo 2, and Photo 3. And I'm going to go to sound now. Okay. Hopefully, can everybody else hear me? So I'm going to grab the play notes. Okay, thank you. Sorry, Joe, hopefully it works. I guess you can't hear me. All right, there we go. So now you can see that I've added the other play note blocks. And I'm going to change the notes just for fun. I'm going to do an E and a G. The last step to our program is to add a repeat so that the students will hear their A and C, their A, B, C pattern repeated. To do that, you go to Control and grab the repeat block. Notice it says 10 right now. So I'm going to wrap it around. So when you drag it to your code, you'll notice it opens up like a C. There you go. And I'm going to change it so that it repeats 3 times by clicking on the 10 and adjusting the number to 3. When you're ready to try your program, you click on the green flag, which is just above the stage, so where you can see my photo here. I'll click on the green flag, and we'll see what happens. So that's going to be a little laggy on your screen, but your own program should work. I'm sure you could hear the sounds there. So the sound would change when the image changes as well. So hopefully you were successful in making the program. If you have any questions about that, I'm going to stop sharing my screen, but please feel free to ask any questions about that. So that's a very simple way to engage your students with making patterns. When we're working with junior students, they seem to enjoy doing that program. And also what you could have them do, some of your students will like dance moves or sports. You could have them take a picture of themselves doing a kick-up of a soccer ball, and then they could repeat that over and over again and look like they can do 100 kick-ups successfully. You can also do some dance moves that way as well. So just some ideas for you. So I'm just curious, before we get into coding with some numbers now, I was wondering how many of you have coded with your students in math class, because I know a few of you do have some limited and considerable coding experience. I'm just curious if any of you have coded with your students in math class. So A, B, or C? Thank you for filling that out. I can see. So we have kind of a split here between those of you who have and those of you who haven't. So again, please share your own experiences with us if you're comfortable, and ask me any questions that we can add to your what you've been doing. Okay. So what we're going to do is some coding in Python now, and I know a lot of you haven't done any coding with Python before, but it's just kind of a neat way to try things out, and it might take a couple times before you feel comfortable using it, but I do encourage you, and maybe after tonight you'll want to give it a go. But how patterns are presented and discussed makes a significant difference to the ways in which students use them to think and to think about math structure. And a lot of the ideas I'm going to talk about today, I've taken from a really good ministry resource that's written by Dr. Ruth Beebe of Lakehead University. So the link is there. You can just Google that to find it. It's one of the What Works under the Ministry of Education's website. So we're going to take a look at a way to present and discuss growing patterns to introduce students to functions, which is the key part of algebra. So you're really helping them to develop pre-algebra skills. And so while I've taken a lot of the ideas from Dr. Ruth-Beebe, I've remixed them by using coding and to help with students understand the ideas that she suggests. So some of the ideas I'll be discussing have been retrieved from this article, and then I'll also share some ideas that I've taken and borrowed from Dr. George Gadonitis, who I will also talk about. Okay. So typically, students are really good at describing the pattern and extending it to the next position, and as I'm sure you know, so if you put up 2, 4, 6, they're pretty good at going to 8, 3, 6, 9. They know the next number is 12. But to extend to the next position might be easy, but they have difficulty extrapolating much beyond the next position, as I'm sure you'll notice. So let's say they wanted the 10th position. They probably have to determine the 4th, 5th, 6th, 7th, 8th, 9th positions first, and that's not very efficient. And this becomes difficult the further down the sequence we go. And when students are doing it that way, they're using what we call additive reasoning. So students aren't able to articulate the math structure of the pattern or predict accurately the number of tiles at any position. And so we'd like to change that. And I'm hoping that by coding, this will definitely help. So students can typically extend the pattern to the next position, but have difficulty extrapolating much beyond. And we want them to be able to predict what number will be at positions much further on, like the 100th position, for example. So here I have 2 sets of data, and students can predict the next number in each set using recursive or additive reasoning, as I mentioned already. So they know that on the left, the next number would be 5, so 1, 2, 3, 4, 5, and on the right, the next number would be 10. So we're going 2, 4, 6, 8, 10. But what I'd like to do is focus the instruction, and as all teachers should do, focus on the instruction on the relationship between 2 sets of values rather than what comes next. So we want to, I'm just going to see if I can use the hand symbol there, but we want to discuss the relationship between this set of data and this set of data. So consider it this way. You can say, what do we have to do to the number on the left to get to the number on the right? Students will notice that they have to multiply by 2. So to get 2 from 1, we just multiply by 2. To get 4, we multiply by 2. To get 6, we multiply 3 by 2. Exactly, so it's explicit pattern now. Thank you, Charlotte. I'm going to go on to the next slide here. So giving them sets of data that aren't in numerical order really refocuses them on looking at the relationship between the 2 sets, since they can't look and easily predict the next number in the pattern as they're not in order. So what do we have to do to get the 4 to become 12? And then we use the same operation for each. So hopefully you noticed that we could multiply by 3. And just so you know, you're going to be using this shortly, but the star means multiply in programming world. So in computer programming, the star is always the multiplication symbol. Great. So again, another example, what do we have to do? And we're looking at the relationship between the 2 sets of data. So your students should be able to say, yes, thank you, said Lorraine, so we're going to multiply by 5. Great. And I like that you got the star there. So you really are doing pre-algebra here. You're preparing them for math in their future years, and they're also helping them to see connections between the data. So it's a different way of looking at it and so much more helpful. I know some of you are probably doing this already, and so by doing the coding that we're about to do, it will help even more. So most students can predict the next number and aren't necessarily challenged by this. So we want to make sure we're really challenging them and using, want to help students to recognize that they can use growing patterns to become powerful tools for exploring algebraic relationships for all levels of learners. We want to challenge all our students. So now we're going to talk about Python. I'm just going to explain a little bit here first. So we're going to learn, I know this is a new language for pretty much all of you, and if you have any questions, or please again, make sure you ask me. So many of the ideas you're going to see in the next few slides are taken from an awesome resource, Coding for Young Mathematicians by Dr. George Gadanidis of Western University. And he researches computational thinking, and he goes into math classrooms often. And so based on his research, he's created this resource, and I've adapted a lot of the ideas from the next few slides from this awesome book. So here you can see we're going to try to make a pattern that goes, just a simple pattern going up by 1 from 0 to 9. And in order to do that, we need to use what's called a loop. So you saw in the Scratch language programming application, we used a repeat. We repeated our pattern. Well, now what we're going to do is we're going to use what's called a for loop in Python. So this takes a little, it's a new thinking here, so just bear with me. But it's the first stage, so there's just 2 lines of code that you're going to be typing in a second onto the console. And it's for x in range 0, 10, print x. And what that means is the first time through the loop, x is equal to 0. This is the range here. And so it will print 0. So this is everything that's indented is part of the loop. So in this case, there's only 1 line that's part of the loop. The next time you go through the loop, x is going to be equal to 1. So we'll print 1. The next time through, 2, and so on. So it goes all the way up to, but not including 10. So in some programming languages, it does include 10, but with Python, it doesn't include the last number. So it's just something to keep in mind, and I'm not really sure why that is. It just depends on what programming language you are using. So let's have a look now that we've discussed what that means. So this is what the output will look like when you run the code that you see here. You will see the 0 all the way up to the 9. So let's get coding then. So what you're going to do is go to this link, and you might try it along with me with a split screen, or perhaps if you have another device. So Python will work on any device. So if you have an iPad, you're welcome to try that out. Any device will work for this. So we're going to go to, as Molly has put it into the chat window, so you can just click on it, bit.ly/Python console, and it will take you to University of Waterloo has created this online console, so you don't have to download anything. And you're going to come to something that looks like this. You will see the console, and the code that you're going to type in is exactly as you see on my screen. So it says for x in range 0, 10, and notice that I've highlighted that there's a colon there. Often a common error will be that people will type in a semicolon, so you want to make sure that you are typing in the colon, and then when you press enter, it will automatically indent the next line. So if you don't have that colon there, it won't automatically indent the next line, so then you would, if you go back and add the colon later, you would physically have to indent so that it knows that this print here is inside of the loop. So I'm going to give you a second now to type that in. When you go to the website, you can see you type it into the console part, and when you're ready, you will click on the Run Program, and you should see this output. So I'll stop talking just to give you a moment to do that now. And please ask me any questions as you go. Oh, God, it works. I've never actually done that before. Charlotte typed it on 1 line, so I didn't realize that would work. Good, so you see the output. Joe got a syntax error. Oh, no. So just look carefully, Joe. It's just going to be a small error, probably like a bracket or a colon. Or a comma missing. It has to be exactly as you see on my screen. Okay. All right, awesome. So I see a lot of people working, and let us know if you have an error. So when you're doing this in class with students, a lot of people will have errors, and actually when I've done this with teachers, we walk around the room and lots of people have errors. And so I always encourage people, and you don't have that option here obviously, to look around at other screens to see if anyone else needs help. So you just check their screen for that error, and this is like the error that you're going to see often. It does tell you a little bit about what the error is, but if you're not familiar with programming, it might be a little more confusing to try and work through. But it does kind of give you an idea of what kind of error. And a syntax error means in programming that you probably just have a spelling error, or you've mistyped some punctuation or something like that. So that is what a syntax error is. A logic error is when you have all the code type right? And then when you go to run it, it will still run, but it won't do what you want it to do. So I'm glad that it works out, Joe. Thank you. So yeah, and then sometimes it's just hard to see on the screen which to use because it does kind of look like a period. So you'll know right away. So students are getting that immediate feedback that, you know, whether it's worked or not. But I always encourage them to look around at other people's screens to help each other out, because they can't stand when other people have bugs in their programs. They want to help each other out. You'll find that right away. So what I'd like you to try to do now on your own is adjust your code to print the numbers 1 to 100, including 100, and starting at 1. And then once you get it, tell us, you know, does it work? Maybe wait a second and tell us how you did it. Jennifer, that's a great question. I actually just downloaded a bunch of resources for really, really cheap. If you send me an email, I can send you links to the resources because I can't remember off the top of my head the name of them. But I also have some resources that my husband actually has made a bunch of worksheets that for teachers, just so that they have like a quick sheet to look at the code, and I can certainly share that with you. So if you just send me an email or remind me after, or send me a direct message on Twitter if you're on Twitter, I'm more than happy to share that with you, Jennifer, just a quick sheet so that you can learn all the symbols. Awesome. So I see, not sure how to say your name, Lixing. Sorry. Awesome. That's right. So your range is between 1, so 1, 101. Awesome. Enter to 100, printed to 99, right? So if you want to switch it to 100, then you're going to switch it to 101. Great. So it's just so that you understand the difference. So it only goes up to 100 in Python, Deanna. Or 99, I knew what you meant, in Python, because it goes up to, but not including that last number in the range, and that's just Python. There are some other programming languages that are like that, but for some reason Python is, and some others aren't. So it's just something in Python you have to keep in mind when you go to type in your code. So up to, but not including the last number in the range. Okay, so we're going to try a couple other things now. What I'd like to challenge you with is to see if you can print going up by 2. So as you can see here, 0, 2, 4, 6, 8, 10, 12, and so on. And so you're going to, if you want to go back to the original code that we had, where it was for x in range 0, 10, you're going to adjust the stuff inside of the brackets on the print line. So don't touch the for loop. Just make sure it has 0, 10, or you're welcome to leave it at 1 and 101. We're just looking to adjust the output so that it's 2, 4, 6, 8. So remember from the beginning that star means multiply. So you won't be able to just write 2x in there. You'll have to write 2 times x. So see if you can get that, and then I'll display the solution on the screen for you. Awesome. Good. So that worked. So some of you might still be typing it. And if I go too quickly, just ask me questions. No problem. So hopefully you'll have something on your screen like this. Yep. Awesome, Maria. So x times 2 or 2 times x. And can anyone give me another way of doing it so that it goes up by 2s? So we can do 2 times x or x times 2, just doing order of operations. So that's one awesome thing about programming languages, is it will do order of operations. So you can have your students learn that way. Instead of using multiplication, though, what else can we do here? Anybody want to take a guess? Well, if we still want to go up by 2s, though, right? So we could use addition. So I'm thinking that we still want to go up by 2. So we could do, there you go, Charlotte, I was just about to type it in. Thank you, x plus x. So that was just another way for this particular one. And sometimes, so that's something you can challenge your students to see if they can figure that out. Oh, no problem. Okay, so can you change it to multiplies of 5 now? But certainly can use division in Python. All right, so multiples of 5. We're just adjusting our code. Okay, so hopefully you had something like this, 5 times x. Oh, there we go. We could do that. Yep, Charlotte, x times x plus x. Okay, so hopefully you were able to, the long way, yeah. And it's great to ask your students to have, to get there in different methods. And some of them, there'll be more than one way of doing it, so it's always nice to have students think about the different solutions possible. So it looks like most of you got 5 times x or x times 5, great. And how did you get repeated addition? Oh, I'm not sure why it timed out. I'd have to try that, Deanna, to check. Might have to just click on the link again. And you can scroll up in the window to get to the link again. Yes, it's awesome to have students talk about most efficient method for sure. Okay, so I'm going to have you adjust the name of your variable right now. So right now in your program, your variable is called x. What I'd like to do is just show you how easy you can change the name. So you were using a variable here. And so the for x, as soon as you typed in x there, it declared a variable. It started to use a variable called x. And then we use the variable in the next line. So what I'd like you to do is change the name of the variable to stage. So what I'd like you to do is have on your code for stage in range 0, 10, print 5 times stage. So you're just, oh awesome, Deanna, thank you. So you're just replacing the x to stage. So Jennifer, I think I have an example later that I was going to show with that. So starting at 3 and multiply 5 each time. So there's a couple of different ways that we could start at the uneven number. Perhaps in your range you might adjust it. Or if you want to do odd numbers, you could do 2 times x minus 1. So you'd have a constant in there of minus 1, Jennifer. You can try that now if you want. 2 times x minus 1 will give you the odd numbers. Okay, so you're able to, make sure that it does work. So a lot of times when I have people change the names of the variables, they forget to change both of them. So please make sure that you do change x to stage in both of them. There we go. So you should have this on your screen right now, and hopefully that worked for you. And just let us know if it doesn't. I'll move on here. So there is an option to add more detail. So this is optional. If you'd like to type this in now, feel free to. But I'm going to explain it, and I'm going to show you a neat feature of the Python console where you can trace the code. But before I do that, I will try to explain this code, and you're welcome to type it in. So you can see above the for loop, I would like to print the word stage, and we know that it's actually going to print the letters S-T-A-G-E because it's in quotations. So that's the difference. We're actually typing the word stage in quotations so that the word stage appears at the top. So this is what's happening in the first line of code. It's separated by a comma. The fancy word for that is concatenation. That's the word of the day. Concatenation, we are bringing 2 strings together with a little comma. And then you can see that I had some spaces as well. So we have spaces in between. And then the title of the second column is number of tiles. Then we get into the for loop. And I have so the stage, again, is going from 0 to 10. Now I've added a second variable. Sorry, I can certainly spell the word of the day. Concatenate, or concatenation. So to concatenate 2 strings together. So here we have a second variable called growing number. And I've introduced that so that I can display both the stage or the term. So instead of stage where you might use the word position or term, but as you noticed on that other image, I had the picture of the trains, and we're going to come back to that later. So in Dr. Garamidis' here's a book that I'll show you, a free online storybook for children, and he uses the term stage for position so that students can picture each term or position being on a separate train stage. So that's the whole story behind why I'm using the word stage. Then you've got the number of tiles. So the growing number is equal to 5 times stage, and then it's going to print stage. So it prints the stage the first time through the loop, which is 0, and then it's going to print the value of growing number. So 5 times stage is 5 times 0 is 0. The second time through the loop, stage is equal to 1 because we're just going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we've got 5 times stage, so 5 times 1 is 5. Then it prints the next value and so on. So students can see the two sets of data on their screen. So that's kind of a longer way of doing it, and you might do that on the second or third day. Maybe just keep simple on the first day that you do this with your students. So I'm going to show you a neat feature for visualizing, and I'm going to try to share my screen for this, and we'll see how this goes. But you can try it now. You'll see the button Visualize on your screen, and we're going to trace the code. So Deanna, just let me know what you try typing in exactly again. So you'll see it on my screen in a second when I share my screen. So it's likely that there's probably just a quotation missing, or is it the visualize that didn't work, or the code when you ran it didn't work? Just let me know, Deanna and Charlotte. And while you let me know, I'll share my screen. The code, okay. So it's likely just a quotation missing or a comma missing. Every little bit is important. Notice too, for the name of the variable, growing number. So I used lowercase and then uppercase. It's just a way of declaring variables. You can choose, but make sure it's all one word. So your variables need to be all one word. That's another common mistake. So I'm going to share my screen with you here. So you'll see the code, the same code that I just did there. So I did just try it right before the webinar as well so that you could see the code. Okay, so just make sure that you're not putting too many colons in, because it will automatically think that you're doing like another loop if you put a colon in, or using something else. So I'm going to click on Visualize, so you can still see my code there, and you'll see it again. And it's really just likely that you have an error somewhere in your code, so it has to be exactly as you see here. So when you click on the word Visualize, you'll then come to this screen, and I'm going to visualize execution, and that will take a second. Now you can see that what's happening here is it's going to show us line for line. So it's highlighting yellow the next line that's going to execute. So if I click on forward here, you can see that it just executed the gray line. So it displayed stage, number of tiles. And this is a really good way to help students debug their programs too. And in this case, it's going to help us to understand the loop. So if I click on forward, it will then do the next line of code. So right now, all it's doing is saying I'm starting a loop, and it's going to start at 0. It hasn't done anything yet. The next line in yellow is going to be executed. So when I click forward, it will then make the growing number equal to 5 times the stage. But again, we haven't outputted anything yet on that stage. So you can see over on the side that the variable values are stored and recorded for you. So you can keep track of the values of the variables on the right. Now we're going to print something to the screen. So we printed the first value, which was 0 and 0. And then you can just go through that. Notice how it didn't go back to the first line, which is the print line, because that's not part of the loop. So right now we're just going between or inside of a loop. So we're just doing each part of the loop. You see? So it's going through. And it just helps the students to visualize what's happening. We call that tracing the code, and it's a really good thing to know about to help debug your program. So I'm going to stop sharing, and let me know if you have any questions about that. Okay. So you can have your students do all kinds of patterns here, and you can have them challenge each other with other coding patterns. So here you've got 6 times x or -5 times x, and see what they can come up with. Yeah, Joe, I couldn't see this doing with primary, or maybe there are some students in grade 3 who you could extend their minds a little bit with this, but yeah, I definitely wouldn't do it with primary grades. I would stick with Scratch Junior actually with primary, maybe a little bit of Scratch. So you can try those out if you want. You can try the -5 times x. So what I'd like to do is show you what this would look like in Scratch. So we're going to do the exact same program, but in Scratch. So if you click on this link, So here we're going to see a Scratch program. So if you click on the link, and then you can run the program by clicking on the green flag. So when you get to this link, it should bring you to a Scratch program. And I'll just let you try and watch it. Yeah, Lorraine, it's a little tricky when you're first starting out because you're learning a new tool while trying to apply it to math concepts. So I think you'll see in a bit we're going to return to that similar program, and hopefully it'll make a bit more sense. So you've got the Scratch pattern too. So let me know if it's running for you. Okay, when you click on Run, you should see a cool pattern come up. Good. So when you click on the green flag on the top of the Scratch program, you will see that this comes up. Yeah, the blue stairs, thank you. So you'll see these stairs. And notice that the code that we need to pay attention here. So I give this link to the students, and again, this is taken, this idea is taken from the researchideas.ca website where you can find this book. So it's 2 times stage. So this here is the only code we care about. Unless you are wanting your students to learn how to program the rest of it, I tend to just give them the program and let them manipulate the math part of the program. So that saves you from having to always start from scratch. Instead, you can have them just focus on the math. So you can give these links to your students and let them play around with it a little bit. So once they've tried that, they can see what happens. We have each term, so here's stage 1, 2, 3, 4, and so on. And if you go to the next slide, here is a comparison between Python and Scratch. So here I have 2 times stage. And in Python, you can see the numbers. In Scratch, we've made it so that you can visualize each part of the pattern. So what if we change that to multiples of 3? So I would just like you to play around in Scratch a little bit now. You can adjust the code. So you're going to just click on the little number here and adjust the code to 3 times stage. And why don't you try 5 times stage? Those of you who are feeling a little bit more confident can play around with operators. So you would go to the operators blocks, which are green, and then you can drag in other blocks and add some constants like -1 or +1, depending on your comfort level. And each block acts as a bracket. So see if you can make it do 3 times x, or 3 times stage, and then run the program. Try 5 times stage, and then run the program. It's really neat because the students are getting that instant feedback. And if it's not working for us, for you, just let us know. And let me know your thoughts on that, maybe. We'd have to adjust the repeat, Joe, so you could add another repeat in there. So right now we've got it doing positions 1 to 10. So you could go up to position 5 perhaps, so repeat 1 to 5. And then you can do a set, so you could copy this whole section of code and paste it beneath, and then just adjust the math there. So Jennifer, I wouldn't actually set this up from scratch. I would use this link. So I would give your students this link, and then they can remix the program. There's no reason why you couldn't do that. So this is publicly shared. So I've shared it with you, and Dr. Gadanitas has as well. So you can just go to this program and then adjust the code. And you'll see right away your students will just go crazy with it. They'll change it to all different kinds of things. Okay, so for Scratch will not work on the iPad, but on the computer, it will work on your computer, Candace. And then we're going to be returning back to Python in a second anyway, so I'm kind of going back and forth between Scratch and Python. Okay. So yeah, the second device was is an option in some webinars. Oh, don't worry, Candace. All right, so we're going to go back to Python now. And I'm trying something a little different here. So you could either try it now, or you can try you could just watch and I'll describe what's happening here. So I'm glad that worked for you, Joe. You'll have to share your program with us all, maybe on Twitter or something. You're on there. You just have to remix and then share it after. So we're going to do for stage and range 1, 10. So we have a growing number is equal to stage times 2. But then what we're going to do, so this is getting a little advanced here. I definitely wouldn't do this on the first day with your students. But if you want them to be able to visualize it just like they did in Scratch, we can do something else. So once you make your growing number equal to stage times 2, so it now has a value, you're going to print the value of the growing number times this. And what that does is it's actually not going to print a number. It's going to print the number, the forward slashes, the growing number of times. So what you'll do is the first time through the loop, it's 1, because I started with 1, right? 1 times 2, so it's going to print 2 forward slashes, because I wanted what this says here is when you put a multiply and then you put after it in something in quotations, so try changing it to a star in quotations, it will print it the number of times indicated by the variable in front of it. So now you've got a nice visual of what's happening. So it's whatever the growing number of times variable is, and it will display the symbol that number of times. It's kind of tricky to spit that out. I think that makes sense. Okay, Charlotte, good. So please play around to any other symbol, just to make sure you can see. So some fun ones would be the star or hashtag, number sign, whatever they want to call it. And you can do some letters in there. You might want to use their initials. Yeah. I think it's just the way I was explaining it, Joe. So go ahead and try that if you wish, and you'll be able to look at this afterwards. The recording will be shared with you all. Okay, so this is taken from the article that I mentioned to you earlier, and you can see here is a pattern with a constant. So now we're going to talk about growing patterns with constants and how you can do this with your students. So you can see this particular pattern. We've got 2x plus 3. For those of you who teach intermediate math, you might have picked up on that right away. And so here's the position, or the stage, on the bottom. And what a lot of students will do is they'll count the number of tiles at each position, and they're noticing that they're just adding 2 tiles each time. But our constant is 3. So we're starting with 3, and then we're adding 2x. So first we have 3, then we have 3 and 2x. Then we have 3 and 2 times 2, and 3 and 3 times 2. So normally students would just tell you the next position number, or very easily they could tell you that, and that would be the additive reasoning or recursive reasoning, but we'd like to get to where they can do explicit and functional reasoning. So recursive reasoning is when we go from one set of tiles to the next, thinking about the next position. So here we have, and we talked about this earlier, but now we're throwing in a constant. So here we have the stage, and then here's the number of tiles. So again, a lot of times they're going to end up just telling you what the next position is, but we want to know the actual expression that they would use to calculate from 0 to 3. What do you have to do to 0 to get 3? What do you have to do to 1 to get 5? And it has to work every time. So here we've got, oops, didn't go to the next slide, sorry, there we go. So here we've got multiply by 2 and plus 3. Multiply by 2 and plus 3. So they might have a different way of getting to the second set of values, but it needs to work for every set. So that's where it gets a little tricky there. But the best thing is to give them a stage of 0, and then they like that because then right away they'll know what the constant is, because when you multiply the variable by 0, they'll get 0. So the constant, that gives it away right away, so they know that it's plus 3 each time. So Joe, I'm just going to read this out loud. So when Minecraft builders create worlds, 2x times 3, or plus 3, I think you meant to write, the type of coding they use to build large-scale structures in. So yeah, you can do this in Minecraft and for sure. So students can actually display this, and they can do it in 3D in Minecraft, which is even pretty cooler. Okay. So the pattern rule provides a generalization for us. So students can test out the pattern each time to make sure it works, then give them, and then I always like to give them other numbers to try out. And of course, as I mentioned, their favorite number will be 0. So here we've changed the order, okay? So the expression, so what's the expression if we've got this? Well, how would you write it out? Any intermediate math teachers want to try and write out the expression for this one? Awesome. Yay. So times 2 plus 3. Thank you. Very good. Okay. So we're going to take a moment now for you to type this in. So I'd like you to try and type this in Python. And again, you can scroll up to the Python link if you'd like to. So try typing this in. So for stage and range 0, 10, print stage times 2 plus 3. So we're having the students see what the output is of the expression 2x plus 3. Okay. And then when you run it, you should see your values coming up. So hopefully you saw this when you did 2x plus 3. And we used stage again, but you can choose what you'd like to use with your students if you want to use the word stage or position or term, and they're just going to see the output. So right away they were able to hopefully code. So you started at times 2 plus 3. So just make sure your starting point, Janet, is at 0 instead of at 1. So you probably had it 1, 10, and then you can change it to 0 if you want it to be stage times 0 plus 3. Okay, great. So let's try another one. So those of you who want to try and work this out on your own, I'm going to put out what the expression is in a second. But take a moment now to figure out, if you can in your head, what the expression is here. And if you don't want to see the answer, don't look at the next 2 screens. I'll let you just have a quick look. See if you can figure out the expression. And if you know the pattern rule now, feel free to type it in. Definitely, I'm sure we're stretching a lot of minds here. So we know what the constant is, because when it's 0, it's 2. You guys are quick. Good. So we got times 3 plus 2, and there's our expression. So can you code that then? Go ahead and try and code it. Just get used to using the program. Okay. So hopefully you ended up with this. Yes, that's right. Great. Awesome. Okay, so we're going to move on here. So you notice that you're getting immediate feedback, and as long as there's no errors, and if there are, no problem, your students will be able to sort that out and help each other, and you'll be able to walk around the room. But the immediate feedback is super helpful for students. They can find out whether they're right with the expression or incorrect with the expression immediately. They're not having to wait to find out. They can test it out and look at the data. And you are going to get lots of errors, so be prepared for that. Your students will get used to getting errors, and it won't stress them out too much. And what we found, the research shows that when coding, students and teachers begin to accept that their failures and their errors will ultimately lead to success. So it's a really good mindset for your students to develop, and you will see that developing in your students when they're coding. It just naturally happens, and same with the teachers, actually. So this is one of my favorite quotes that I like to share. So Mindstorms is a book written by Seymour Papert, and it's actually he wrote it in the 80s, so a long time ago, but he was really forward-thinking with everything. And now things are just more accessible for everyone to do some coding. So he says in this book, typically in math class, a child's reaction to a wrong answer is to try to forget it as fast as possible. In coding, however, the programmer is encouraged to study the bug rather than forget the error. It will pay off. So I just love that quote so much. It's it's so valuable, I think, for math teachers. And this is not exaggerated. This is often what you will see with your students when they debug their code. And teachers too, they just feel so excited when it works. So there's an opportunity here too for just-in-time teaching. So a lot of people, when they see that, they will ask you, and a lot of teachers will ask me, well, how do I put headings on this? Or can I display, instead of just displaying the total number of tiles, can I also display the stage and the growing number as well? So I'll show you an example of that here. So yes, Mindstorms is named after, the book Mindstorms is named, or the Lego kits rather, are named after the book. So for those of you who have coded with or played around with Lego Mindstorms, it was named after that book. And yes, Dan, he did do Logo many years ago. So it's awesome that you had that opportunity to use Logo. So here's an example of, you're welcome to try this out or just look at the slides. I'm just going to go a little quicker now. So here we have the variables. I've got a couple variables now. So I have the stage, and I'm indicating I'm starting at 0 and going up to 9. So up to 10, but not including 10. And the growing number is stage times 2, so that's like x times 2 or stage times 2. Then I have a constant. So I've separated now the growing number and the constant. And then I'm going to print all of that like so. So here I've printed the terms for the stage. Then I put some quotations with spaces in between so that it separates it nicely on my screen. So that's why there's the space here. Then I print the growing number value, which is the stage times the 2. So the first time through the loop, 0 times 2, 1 times 2, 2 times 2, 3 times 2. Then I'm going to print the constant. So it's printing out all of those. So then I will challenge some students to see if they can code it by including the total as well. So on this other line, I've added another variable that adds the growing number and the constant, so it's total equals growing number plus constant, and it will total that each time through the loop. And I know that this is probably, really challenging some of you right now, but I do encourage you to try watching it again, and you'll see that the more you do it or the more you hear it, it starts to just make sense. So we're printing now the stage, or the term, the growing number, the constant, which is the same each time, and you can look up how to format Python a little nicer than it is here, and then the total. So here are the total tiles, and you've got the other, some other data as well. And for this one, all I've done is added that first line above the for loop. Yeah, Alexis, I understand. It's really like a big concept that we're learning here. We're learning a new tool, a new language, and applying it to a challenging concept in math. So here we've got a print, so we're printing the term, the growing number, the constant, and the total at the top, and it only does that once because it's not inside of the loop, and then it does the rest of the program. So we're creating some data for ourselves to look at here. So I'd like to just share with you some resources. This is a storybook, so you can go to this link if you want to now, and you'll come to a book called Math Train. And this is a free online resource. So it's called it's mathsurprise.com website. And I just see some questions here while you're typing in that resource. If Natalie is listening, she can maybe type in that in the chat window while I answer these questions. So Charlotte, how many spaces between the quotations? Well, you can decide that, Charlotte. I don't remember what I used. I just think I did it randomly. So maybe 5 or 10, and that just separates the data. And can use this in primary grades too. I probably wouldn't use this with primary grades unless you have some students that you'd like to challenge a little bit. And as long as it's consistent, I would be awesome for, yeah, I would keep it consistent, Charlotte. Sorry, I was thinking it was just the same question. So what I would do, Lorraine, is if you want to try it with primary grades, let me know how it goes. I don't know. I think it might be a little tricky to add the constant for your growing patterns, but certainly going up by 2s, like 2 times something, might be a really cool exercise to see what they do. So when you go to that link that Molly has put in the chat window for you to click on, you'll come to this. You'll notice it's in English, French, and Spanish. So you can read this on the smartboard or on your projector with your students. And it's a little storybook looking at growing patterns. And so I've done this with my own children. They get to try out everything if I don't have a class at the time. And so here they're able to predict what the next stage is, and then you can have them start to learn how to describe these patterns using expressions. There's also a lesson plan on the website, and you can certainly read this book learning to your primary students. So this is definitely something you can do, and you could have them try and figure out what the next, how many blue blocks and how many red blocks would be on the next train. So for sure this would work with the primary students. But the coding part, you'd have to decide if you think that is possible. And I encourage you to let me know if you do give it a try. I've never tried the Python with primary students. Okay, so growing patterns, what you could use is just manipulative. So I encourage you to not just code with students, but also use manipulatives, as I'm sure many of you use all the time. So here we would give little pieces of paper, or you could use those little cubes that attach together, or Lego bricks. And here we've got 3x plus 3. So the plus 3 is the red. So we know that it's 3 every time. That's called a constant, which is great because in programming we use the word constant all the time. Then we've got variables. So we have 3x. So we have 3 times 1, 3 times 2, 3 times 3, and so on. Yes, Jennifer, there's a number of stories that you'll see on there, and it's wonderful whenever, as you said, to connect literature to mathematics. So I'm going to go to the next one. Here we've got the opportunity for them to use their manipulatives. So this could go along with the story book that you would read with them. Have them do the display these using their manipulatives. I just cut up little pieces of paper, but again, you can use blocks. One of my pre-service teachers once said, actually, why do we put the constant on the top? When you're doing, for those of you who teach linear functions or relations, you can actually have the b value would be that plus b, like y equals mx plus b. So the plus b is where it starts on the y-axis. So you could put the constant on the bottom to get them used to knowing that that's where it starts on your graph. Okay. So here's a picture of my children, my two oldest boys. I have 3 boys, and they're using the manipulative, and they were looking at the book, and they were also, by the end, because we talked about it, able to write the expression at each stage. So you could do that with your students by 2x plus 1. So you can see they do the manipulatives, and then you go and have them code it as well. So first you could have them try making the 10th stage with the manipulative without going to do every stage in between, see if they can go right to the 10th stage. And before I show you how or suggest that you code it with Python, I do want to point out that in the Ministry of Education math curriculum from grades 1 to 8, it talks about the use of manipulatives, and it's really good to use them with patterns. But you'll see that when you use it with coding, I really feel like this is actually providing a definition of coding manipulative. So coding can be your powerful manipulative. So when you're coding, you're making connections between the concrete and the abstract. They're typing in a variable and then clicking play, and then they see what the nth term is. So they can type in like 1,000 or 2,000, and very quickly they're able to see the abstract concept. It becomes, as Dr. Gadanides would describe, tangible. They can almost feel that variable because they type it in and they see the results. So it's pretty neat. I know that, Joe, I feel like there's so many aha moments when you're coding, and same with the pre-service teachers. When they did this there, they're like, oh, I never thought about it like this, and it's like looking at it from a different perspective. So it definitely makes it more of a visual for everybody. I think a lot of teachers feel that way, Joe. So you'll find that coding debt is a really powerful manipulative, and it's similar as using other manipulatives, but I feel like it's even more powerful than the blocks. So I'd like to have you watch this video, and you can either type this in yourself, or we could try doing the screen share if Molly wants to do that for us. But for those of you with an iPad, I think you actually have to type this in. It's only like a 40-second video or 50-second video, and it's of my pre-service teachers describing doing this exact activity in our class. Thanks, Molly. Their own time. What an awesome idea. Weishing. Sorry, I don't know how to say your name. but that's a great idea. Awesome. Thank you, Molly. Okay. So you saw in that video the pre-service teacher doing the 4x plus 2, and they also added the total as well. And so they had to do it with the manipulatives and with Python. And I think it was neat for them to see it with both ways. So here's something I'd like you to try. We have just the right amount of time left to do this and then talk about a few more things. So I thought we could program what this train is showing. So here we have going up by 3s, and we have the constant of 2. So you can do 3 times x plus 2. And what we're going to do is we're going to name the growing number part blue and the constant red. And then we're going to print blue, comma, red. So see if you can try typing that in to Python right now. And you should your output should end up with like 3, 6, 9, 12 like this, and then the constant on the right. And some of your students like to go up to 1,000 or to try different numbers, and of course, it's great for them to try that out, encourage them to do so. Okay. Let us know if you have any errors that we can help. Well, Mary, if you do it, let me know. I'd love to hear how it goes. And if you have any questions, please email me or send me a message, and I'm happy to answer that for you. I find when we do things like this on webinars, or if I do in-person sessions, I'll give some ideas, and then teachers will send a message or a picture or a video of their students doing something way cooler. So they take an idea and they remix it, and I get even more ideas to try. So it's really neat to hear back after to hear how it goes. So hopefully your program, you were able to get that working. Hopefully I gave you enough time. What I'd like to do is try out another program. You're just going to type this in and go to the link. And I would like to show you an example of using a constant in Scratch. So again, it's the same thing. I wouldn't myself have the students make this whole program from scratch. Sorry, the pun again. I would instead give them the link to this program and then allow them to adjust the code. So there's 2 parts to this pattern. So you're going to see this, and Molly has put the link for you, so you can just click on it. It will take you right to it. So here you can see, again, this is taken from Coding for Young Mathematicians. So we've got the 3 times stage, or 3x plus 2. So here's the blue part. And you can see blue blocks are doing your growing part. And then the constant is just repeating 2 every time. So every time it's just going to stamp the 2 blocks. So I'm going to ask now that you try to change it to 2x plus 5 and see what happens. So try running your code. How you would do that, I've commented the code, so I've indicated to you here that here's the growing pattern part. So here's the first part of the expression, and here's the second part of the expression. So let me know if you have any questions about that. Awesome. What great advice. Let your students do it and you stand back and let them teach you. So once you do give them the basics and then challenge them a little bit, they'll just start challenging themselves and challenging you and teaching you all kinds of ideas. It's wonderful. As long as you're comfortable with that, it is getting out of our comfort level and allowing our students to teach us as well. But it's such a wonderful learning opportunity for them to be leaders and to feel like they're able to help others. So hopefully you're able to get something that looks like this on your screen. Awesome. Wonderful. It's so neat when we step back. My own child said to me the other day, Mom, I find that adults tend to underestimate what children can do. So it's just really neat to hear the wisdom of young people. And all my students so often, especially teaching computer science for so many years, there's so many students that are way better programmers than me. They go home and they practice for hours and hours, and they get to the point where they're always teaching me new ideas as well. To do the comments, Deanna, so the little sticky notes are called comments. And what you do is you should be able to right-click on the blank part of the screen beside the code, and it should come up with comments. Now, sometimes if you're using a certain web browser, it won't come up with comments, so you would just click and paste the link at the top of your screen into a different browser, like Explorer or Chrome, and you'll end up, oh, it's worked, okay. Yeah, so I often give my students instructions with the comments, so I'll give them a link and then I'll say, do this with your code, and then they'll be able to know what to do. Okay, so what I like to do is to have students challenge themselves and each other with different expressions. So what they'll do is they'll type out an expression. So this is what I do with my students sometimes. And I'll get it to print, so I'll run the program. But then I'll take out the expression and I'll just say like something like enter expression here, or I'll just leave it blank. And then I'll screen print it and show them. And I'll be like, can you code this expression exactly? And what's great is you've already tried it, so you know the solution and you know that it works. And then the students keep trying until they end up with the same numbers. So they're playing around trying to get the same expression that you've got. So here's the solution here. So for the one that I posted, so you can see it right now, it says enter the expression here, because all I did was run the program and then I just changed it so that it didn't have the expression anymore. And then I'd let the students try and figure it out. So here we've got 4 times stage plus 5, and there's the solution. So you try and challenge them to do all kinds of things. So here we've got another one. Does anyone want to guess what the first one is in the chat window? So we've got 1, 6, 11, 16. And I start at term 0, so we know what the constant is. So what would the first one be? What would pattern A be? What would the student type in here to get this output? I hope you're out here. Maybe, yep, some of you might even be doing it. Thank you, but that's right, good. So 5x plus 1. And then this one here, I've used a negative constant, so it's 3x minus 2. So you can do that as well with your students. Now this is a handout. I'll let you click on it if you'd like to, or type it in. So this here is like a little handout, and I know that sometimes we don't like to use handouts in math, but it's differentiating it for you. So if you go to the link, you will see that there's a whole bunch of different examples, and it starts with red, yellow, and green. Thank you, Mal. She's got the link there for you. So the red problems are ones that are a little easier, so students can choose to try and code those ones first. Then they can move on to the yellow. Then they could try the green. I think I might have a quadratic in there. I don't think I did, but sometimes I do have students. They could even do that in Python. So there's 3 different levels for your students to try. So some of your students might just stick with the red ones. Some of them might do the green ones, and some of them, or some might do yellow, and some might do the green. Also, what I like to do is have some of those programs in my back pocket. So as I'm walking around and if students look like they need a little challenge, sometimes I even might have the harder ones on the bottom and the easier ones on the top. And depending on the student, I might just give them one of the cards, either from the bottom or the top, and challenge them with all different ideas. So all I do is screen print the output, and they try and determine what the expression is. So for the next couple slides, I'll just show you a couple things before I wrap up. So you won't have time to type all this in, but you can go to this link afterwards, or go to the webinar afterwards and pause it. So I'm just showing another way to make it more of a visual. So here I've got the stage or the term number, and then I show them the value of the total number of tiles, and I've used different symbols for each. So here I've got the growing value, and then here I've got the constant. So it's just kind of a neat way for students to see it in a visual way. A lot of people like this way. And some students just like the numbers. Then I also would challenge them to just print the 100th stage. So here I've just typed in the exact code, 100 for the 100th term, times 2 plus 3. So that's something else for an extension that you can try with your students if you have the time. So research shows that very young students can develop an understanding of functions, and functions is sort of like you're providing them the precursors for, or you're setting them up for algebra. And that's exactly what you're doing with this sort of thing. So for older students, you can start working with linear patterns, and it shows us an effective introduction to a graph of functions, which I'll show you this in a second. So here's an image taken from that resource I mentioned to you on the Ministry of Education website. So we've got the constant of 1 here. So for the first graph, it starts at 1, and then we've got the variable part. And it's the same here, so we've got times 3 plus 1 again. So they're all starting at 1, so you get your students to realize, oh wait, if the constant is always 1, then that means it starts at the 1 on the y-axis. So it's always good to use a real-life example. So a real-life example would be, if you're paying $10 a month for your mobile phone, that's a constant then, so you would start at 10, and then it's times X for every text. So then it's, or times 10 cents for every text. So 0.1 multiplied by X. And so your graph, that would be the rate there. So it's just, you're doing the same thing, but you're doing it with graphing. And so it's a great way, a next step for your students if you're teaching the older students. So a little summary of what we talked about tonight. It's really important that you make explicit the connection between the position number, the stage as we called it, and the number of tiles. And instead of asking your student what comes next, ask about the faraway position, so you're getting into explicit reasoning. Make sure to use those physical manipulatives to build the multiplicative reasoning and value of position. So we're thinking about positions rather than just what comes next. And be sure to ask your students to consider which number affects the steepness. I didn't talk a lot about that, but let them change the values in Scratch and ask them, what if we change the variable or the constant, which one will adjust the steepness of your graph? And get them to try it out to find out the answer. That's the learning through discovery. And of course, when students discover something, they will remember it for a lot longer because they had to figure it out themselves. And again, these are taken from this ministry resource, and then I just added the coding twist to it. So it'd be a great idea if you're able to code with your students. And of course, like I said, I'd love to hear how it goes. So you're setting them up for success in algebra and helping our young students to make this conceptual shift. That is your ultimate goal. And I'd just like to share with you, so I mentioned that as a research assistant, I've had the pleasure to work with professors who are researching computational thinking, and this is from Donna Katstopoulos of Laurier University, and she and is one of the lead writers of this project. And what we found is this is a great way to consider computational thinking, so you don't actually have to go in order when you're doing this. You might start off with some unplugged activity with your students, and I haven't shared a lot of unplugged on this particular webinar, but on the previous one I did on patterns I did. So you've got unplugged activities, then you get into tinkering, so playing around with the code in Scratch or playing around as we did in Python. Then students can actually make their own things, and then we get into higher order thinking where they actually remix and do something totally different. So it's just an idea for you to to think about computational thinking, and the purpose of this is to, maybe you can do it in order to help yourself and your students get more comfortable, but you don't necessarily have to do it in this order. And in order to fully experience computational thinking, your students should be doing all of these things. So I'd like to mention a resource for some of you. You might want to check this out. It's mathandcode.com, as you can see here. And there's a bunch of different articles that are written by teachers, researchers, and I've had pre-service teachers right on here. So it's an awesome resource for you to check out. It's edited by Dr. George Gadanides, and if you'd like to write an article to have your work published on this website, maybe you're trying out coding for the first time and you'd like to share how it goes, he'd love to hear from you. And you can also try, or even if you've done a lot of coding, so just all different levels of experience are welcome to write an article for this website. So I'm going to skip down here. I will say that computational thinking has shown to have a really a powerful impact on all areas of student learning. So when you're doing this, it's awesome if you can enhance understanding of math ideas when you're doing coding. You will see that you're making connections. A lot of you, I think, had a couple of aha moments here, or you will hopefully when you go back and try it again. But there is that option, but it also, you're helping them with their learning across all subject areas by incorporating coding into your lessons. And ultimately what we want for our students is to become thinkers rather than storage bins for thinking about others. We want them to become independent thinkers, and it's just an awesome quote that I found. I think all teachers would feel this way, and I believe coding helps that. So thank you so much for joining me this evening. I've done a little loop here showing you. Thank you 5 times. I appreciate you taking the time this evening to join me. If you have any questions at all, I'm more than happy to help you out with this. And again, I'd love it if you could share some of the work you do with your students. Thank you very much. Thank you, Molly, as well, for doing all those links and videos and helping me along here. Thank you, everyone. You're so kind. Better late than never, for sure. Don't worry. Oh, Molly's mic's not going on. I'm just going to point out. So there is a link here.